What up, world? It's Dana Harris again, and I'm making math cool again. Today we're going to be talking about some trig functions. Now we're going to keep it basic for the first two lessons, and we're just going to talk about the simplest things in regards to graphing a trig function. So let's go ahead and get right into it. We're going to be talking about the sine function today. Okay, sine, S-I-N. That's how you see it most of the times, but it's actually S-I-N-E. So we have the sine function. It looks like that. Now we also see it as just S-I-N, but that's the sine function, okay? And here I already have the graph of this sine function drawn. So we could write this equation as y equals sine x, or we can write it as a function in function notation, f of x equals sine x. And we're just going to talk about the basic parts of this sine function graph, okay? So the first thing we want to talk about is the amplitude of this graph. So the amplitude of the sine function is actually the how high the wave goes, okay? So when I go from this center point, notice here the x-axis is the center point. So basically the amplitude is just how high that graph goes from the center to the maximum point. So this is also another word. We have the maximum. All right. So that's the highest point on the wave. Okay. And also the amplitude can also be determined from the middle to the lowest point. Okay. So this is the amplitude as well when we go from the center to the lowest point on that sine function graph. Okay, so we have an amplitude, we have the max, and then the lowest point is going to be the minimum or min. Okay, so we have the maximum, the minimum, we have the amplitude, which is the distance from the center to the highest point on the wave, as well as the distance from the center to the lowest point. So the amplitude is always given an absolute value. It's going to be positive. Okay, now the next thing we want to talk about is the period. And the period is the amount of space that it takes up to go one full wavelength. So if you notice, one of the key points to the sine function is the sine function, it starts at the origin. So it is always going to go through the origin when you have just the basic sine function. Okay? So it starts at the origin and then it goes all the way to a maximum point at pi equals at pi over 2. Notice on the x-axis, we're counting in terms of radians, okay? So at pi over 2, it's at a maximum point. Then at pi, it comes back to the center. And then at 3 pi over 2, it goes to the minimum point. Notice here the amplitude is 1. It goes from 0 to 1, and here 0 to negative 1, okay? And then we come back down to the minimum point at 3 pi over 2 radians, and then we go back to the center at 2 pi. So the period for the basic sine function equals 2 pi, okay? So the period is nothing but the length of a full wavelength. That means it goes from the center to the maximum point, back to the center, to the minimum point, back to the center, okay? And just for the sake of showing you guys, we could actually extend this back again, and it would make the same pattern. Okay, we could extend it. If we extended this x-axis, boom, so this would be another full wavelength. Okay, so this would be actually here 5 pi over 2, and then we would say 3 pi here, and then 7 pi over 2, and then 4 pi. Okay, 4 pi. So that's just an extension. So we have 2 full wavelengths there. But the main thing is we want to talk about the amplitude. We want to talk about the period. We have the maximum point, the minimum point. So these are the basics of the sine function graph. Okay, and notice we're going to get into some more detailed information when we talk about what happens when we do transformations on this graph. So that's the sine function graph. Dana Harris, Young Guru's Math Tutoring. I got the solution to your math problems.